Good afternoon. Welcome back to our video series. This one's on chemistry. Today we're going to be looking at stoichiometry, and I'm going to help you get started on your first 8 problems. Here's the notes. This is our Unit 6.2, stoichiometry notes. And where we're going to be getting started today is specifically we're going to be just looking at doing this first problem down here. This is all I'm going to do, number 1. We're not even going to look at excess and limiting reactants or anything today. We just want to get through this first part about like molar conversions and what molar conversions means. Now, this is what's neat. You spend all this time in chemistry. You learn how to write Mg plus 2 OH negative 1, and you learn all this kind of stuff. You learn how to balance equations and all this stuff early on. And now for the first time, 2H2O. And let's say that decomposes into 2H2 plus O2. Now for the first time you actually get to use a balanced equation for something. In other words, these numbers, 2, 2, 1, they're actually going to be something used in a mathematical sense for the first time. And so really what this means, and you got 2 different ways of looking at it. You could say that this means, and I've seen people try and draw this out and be like, okay, what this means is that for every 2, we can use different colors. For every 2 little water molecules, I always like water, it's kind of Mickey Mouse. For every 2 molecules of water, we are going to make 2 hydrogen gas molecules, and you will make 1 oxygen gas molecule. So that's what some people will say this kind of represents. All right, but here's what it means in terms of our sense. To us, these numbers tell us moles. It means this. This tells me if I have 2 moles of water, 2 moles of H2O should make 2 moles of hydrogen gas. Ooh, hey, look at this. Doesn't this look a lot like 12 inches equals 1 foot? All this is a conversion factor. For every 2 moles of H2O, we should make 1 mole of O2. Whoa-wee! It's another conversion factor. Y'all, all that's going to change is this becomes our conversion factors in this. So, here we go. We're going to pull this kind of back a little bit. And now let's go ahead and do like our first example up here. I'm going to show you what this means and the significance of it all. Alright, so my first example, and I'm going to do example number 1 that's on here. Example number 1, see if I can get this. It says that magnesium chloride is reacted with silver nitrate, and that produces MgNO3 plus AgCl. Now what's funny is on this paper it's balanced, but it's not balanced right. There's a 2 there and it doesn't belong there. So anyway, so we need to balance this equation, and we can take a look and balance it fairly quickly. We can just put a 2 here, and we can put a 2 in front of the AgCl, and now we got our balanced equation. Y'all, this is the crazy thing about stoichiometry. All we need is one number. Give me an amount of MgCl. Give me AgNO3. Give me anything. Give me any number across here. I will tell you every other amount made or needed if you give me one single number. Alright, so this problem, question A, it says that I've got 12 grams of magnesium. So I'm going to slip over here and write that down. I've got 12, it's not hardly bold enough of a pen. I've got 12 grams of magnesium. So I've got 12 grams of magnesium. And the first question says, how many grams of silver chloride are made? So my first question is this. So I'm given 12 grams of this and ask for silver chloride. Well, what I'm going to do is this. I need to convert, and that's all we're doing. I need to convert my 12 grams of MgCl2 into grams of AgCl. So, like all conversions, I'm going to start off and I'm going to write down. See if I can get this up in a good spot. 12 grams of MgCl2. Draw my line, put my X, draw my line. Now, just like we learned on our molar stuff last time, pretty much everything, moles is the center of it. Before you can make this, and I like to call this, you're going to hear me say this a lot, and some chemistry dude may watch this somewhere. Well, good on you. I don't care. Here you go. I like to call this a jump. Literally, it's a jump. We are going to convert from this and jump over to the AgCl. But before we can make this jump, we have to be in moles. We'll jump out of the moles, we'll land in moles. So we have to be in moles to make this jump. So the first step of my conversion, before I can jump, is I've got to convert this to moles. So magnesium weighs 24, chlorine 35 times 2 is 70. So we've got 94 grams of MgCl2 for every 1 mole of MgCl2. Put my X, draw my line. I'm not done yet. So this was the first step. I have to be in moles. And now you get to do your new thing. Look up here. For every, no number here means basically there's a 1 here. For every 1 mole of MgCl2, for every 1 mole of MgCl2, I should be able to make, jump 2 moles of AgCl. So equals 2 moles of AgCl. Well, you already know what my next question is going to be. Do we write this on the top or bottom? If this says mole of MgCl2, this bottom has to say mole of MgCl2. So 1 mole of MgCl2 per 2 moles of AgCl. So there's our, look at where we are. What would happen if we put an equal sign right now? If we put an equal right now, we would have converted to moles of AgCl. I need to do one more step. I want to get this answer into grams. So I'm going to put one more X, one more line, and I'm going to convert AgCl into grams. Well, for every 1 mole of AgCl, we have Ag weighs 108 plus 35, 143. There's 143 grams of AgCl per every mole. And now we're ready to equals. We can get an answer for this. So we've got, clear that out, 12 times 2 times 1, 43, divided by 94 on bottom, 36, and I'm going to write it down a little bit so I got more room. But the answer is 36.5 grams of AgCl. Put me a box around that. That is your first basic stoichiometry problem. Started with the MgCl2, and we jumped over here to moles, and then eventually to grams of AgCl. Now, do something. Some teachers will have you like mark all this stuff out as it cancels out. I don't like to do that. But just take a look. Grams, if you've got grams of MgCl2 here, you better have grams here. Grams to grams of MgCl2. Moles of MgCl2, moles of MgCl2. Moles of AgCl, moles of AgCl. It's just a way of looking to see if you've done this problem right. All right, now, question B actually asks, for me to find how many grams of silver nitrate. So it says, question B wants me to do this. It wants me to find the grams of silver nitrate that I need in this problem. So, next thing I'm going to try and do is figure out this grams of silver nitrate that I need in this problem. So my next jump is going to be here. I'm going to try and jump from here to here. So there's my next jump. Now, just like this jump all the way across here, so I said, give me one number. I can tell you how many grams of this I need. I can tell you how many grams of that I'm going to make. And I can tell you how many grams of that I'm going to make. So now I can come back down here in this problem, and I'm going to start it off again. I'm going to start with 12 grams of MgCl2. I'm going to draw me a line, put me an X, draw me a line. Now, this is what's handy. Once again, even if I'm just jumping from here to here, converting from MgCl2 to AgNO3, before I can jump, I have to be in moles. So I basically got to repeat the same first step from up here. So for every 1 mole of MgCl2, it's going to weigh 94 grams of MgCl2. X line. Put my mark down across here. Now, what is my molar relationship? This jump has a formal science name. This little step I call the jump. In the real world, we call that the molar relationship. But doesn't jump sound so much more fun? Alright, so what is my molar relationship between MgCl2 and AgNO3? For every 1 mole of MgCl2, I should make or need 2 moles of AgNO3. So MgCl2 is on top here, so MgCl2 needs to go on bottom next. So for every 1 mole of MgCl2, I need 2 moles of AgNO3. And if I wanted moles, I'd be done. But I want one more step. I want to convert this all the way to grams. So I'm going to put me an X right here, and I'm going to draw me a line. And see, AgNO3, let's see if we can add up how much that weighs on here. Be 108 plus 14 plus 16 times 3 is 48. Ooh, I put times instead of plus. Plus 48, and that's equals 170. So there's 170 grams of AgNO3 for every 1 mole of AgNO3. I'm going to put me an equal sign down. Now I'm going to grab my calculator. I'm actually done with this one. So let's see if we can do this. We would have 12 times 2 times 170 for the top equals divided by 94 for the bottom, 43.4. 43.4 grams of AgNO3. And there we go. That is our answer. This is basic stoichiometry problems. They're not any harder than this. Matter of fact, this is the hard ones. From here, the questions actually get easier. So anyway, I hope this helps you get started on the stoichiometry. What you need to do at this time is I've got 8 questions. Do number 1 through 8 and see how you do on those, and we'll check our answers on those. Thank y'all.